Okay, so today, 5/22/19, okay? So, if I take a look at problem number one, there's a couple of problems, a couple of major problems. One, it's not a right triangle.
Not right.
So we could drop down, and we could get the height. And once we get the height, we can go from there to get the height, then you can find some of these angles, but it's really pretty hard to solve this triangle if you don't have a special formula. No opposites, you guys read? No opposites, but there is a cool formula. So it's the law of cosines. So here's what you need. You need side, angle, side. And that's what we have. We have side, angle, side. Yeah, SAS. We've got side, angle, side. We've got a side, an angle, and a side. And when we say side, angle, side, in geometry we learned if it's side, angle, side, then the angle that we know is in between the two sides we know. So it's the inclusive angle. That's what we have, is the inclusive angle. So what we can find then is the opposite side. So we can find the opposite side. Okay, so it is a big equation. So let me real quickly redraw this triangle in, general terms. Theta, adjacent, adjacent, and opposite, okay? And that's what we have, is we have my two adjacent sides, and my theta, okay? So that makes my 10 my adjacent, and my 11 is the adjacent, and then 50 is my theta, okay? I'll let you catch up, okay? I'll let you catch up. Now, well, I'm going to white this out, because the form is actually kind of long. White this out. So it's a long formula. It's going to seem like, oh, are you serious? But just type it into your calculator, okay? So here's my opposite side, right? We'll call that little a. So the formula is this. Opposite squared equals adjacent squared plus adjacent squared. Adjacent 1, adjacent 2.
Oh, so it's like Pythagoras theorem?
Yeah, a little bit, yeah. Minus 2, and 2 is part of the formula, okay? Who are you looking for?
Oh, Morgan.
She's not here. 2 times my adjacent times my adjacent times the cosine of the angle. Okay, write that down. That's the law of cosines. Pretty long, isn't it? I know, it's a pretty long formula, okay? Hey, don't feel bad. Can you imagine doing this without a fancy calculator? Welcome to my world, huh? And I majored in math. Can you imagine that? What am I, crazy?
Very.
Yeah. So here's how it works. It's actually pretty easy. So this is my side A. Do you want me to give you a chance to write that down? Am I going too fast? I can slow it down. Give me, hey, Mr. Davies, just chill. If you say just chill, Mr. Davies, I'm good, okay? Okay. Give me thumbs up when you're ready. I'm going to highlight that while I'm waiting for you, okay?
Ready.
Come on, highlighter.
I'm ready.
Are you ready?
Ready.
Ready to rock and roll? Alright, so highlight that. Okay. So here we go. Ready? We have side, angle, side.
Yeah.
The 10 is an adjacent side because it's next to my given angle. The 11 is an adjacent side because it's next to my given angle. That makes them adjacent. They're next to us, like next door neighbors, right? The A, side A is all the way to the opposite side. That makes it the opposite. So here's what I'm going to do. I'm going to go A squared equals, because that's opposite squared, equals 10 squared plus 11 squared minus 2 times 10 times 11 times the cosine of 50 degrees. Okay? And just plug numbers into my formula. That's all I did. Just So put the numbers right into the form, okay? So my calculator, just going to do the same thing. I'm just going to use my calculator. I'm just going to plug it in, okay? So we're going to go 10 squared plus 11 squared minus 2, because that's in the formula, times 10 times 11 times the cosine of 50, and I get an answer. Now, that is not the answer because that's a squared. That's a squared, right? So, yeah, so a squared is equal to 79.58, blah, 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 blah. I totally agree, Daisy. So we square root, right? Square root that answer. About 8.9. So that side is about 8.9. Okay, so let's put that in there. 8.9. Okay, now I know 8, right? Okay, now, if I need to solve the triangle, then what I could do is go back to what we've learned before, because now I have a pair of opposites, don't I? So I have a pair of opposites. I can get either angle B or angle C. It doesn't really matter, but I have a pair of opposites now. So let's go find, how about angle C, okay? So now I'm going to find angle C. So I'm going to find the measure of angle C, but I'll use the law of sines. Because I have my opposites, right? Okay, so I'll go sine of angle C over its opposite. 10 equals sine of 50 over its opposite. Right? And then I'll just solve like I did before. I'll multiply up the 10, right? So I'm going to go 10 times the sine of 50 divided by 8.9. And I get a decimal. I anticipated that because I'm going to have to do the sine inverse of that. So it goes sine inverse of that 0.8607, blah, 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 blah. But I'll use the answer button, right? So I'm just going to go sine inverse of that answer for accuracy. And I get about 59.4 degrees, okay? So I get about 59.4 degrees, okay? Okay, how am I doing? Now, angle B is easy. You guys agree? Angle B, because I'm just going to get angle B from 180 degrees. So I get angle B, the measure of angle B is equal to 180 degrees minus my 50 plus my 59.4 degrees, right? Let's use my calculator, 180. You already got it, that's awesome. 50 plus 59.4, thanks Daisy. 70.6, right? Okay. What do you think? Now, finally the area. Now the area goes back to a formula we learned on Monday, right? And so the area is equal to the 1/2 our adjacent times our adjacent times the sine of theta. That's our area formula, right? That's our area formula. We learned that on Monday, right? And if you right, so area is going to be 1/2 my 10 times my 11 times my sine of 50, and I'll get the area. 0.5 times 10 times 11 times the sine of 50, and I get an answer of, 42.1 centimeters squared. How am I doing? Thumbs up? Now, if I wanted to find the angle, you can actually find an angle, okay, from the law of cosines, okay? So let me flip the page, okay? So if I take a look at this example, here's the bummer. You don't have any opposites. You have three sides, so you do have three things. You have to know three things, but you don't know any angles. So we're going to use the law of cosines again. So what I'm going to do, and I'll do it, is I'm going to take this formula, and I'm going to solve. I'm literally going to solve for cosine of theta, okay? You don't have to, but if you were to take this formula and solve for cosine of theta, then you'd be able to have all your sides. So you'd have all your sides. You have cosine of theta equals all of this. So the formula looks like this, okay? So, law of cosine. So if you know side, 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 which we do. We know all three sides, right? If you know side, 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 then you can find an opposite angle. Okay? And the formula is like this. It's going to go cosine of theta equals parentheses. Absolutely have to have parentheses. Parentheses, 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 parentheses. Got to have parentheses because if you don't have the parentheses in your calculator, it's not going to divide correctly. Okay? Parentheses. We're going to go adjacent squared plus my adjacent squared minus my opposite squared. Parentheses. So we have the entire top divided by parentheses 2 times my adjacent times my adjacent, okay? Parentheses. Don't forget your parentheses. Now, what I will get is a decimal, because I've got cosine of theta, right? This should give me some decimal. So the last step would do cosine inverse. So we'll do cosine inverse of that answer. Does that make sense? Because this is going to give you decimal. You want to find the angle, so the last step will be cosine. Okay? So if I take a look at my triangle, am I going too fast? Give you a minute or two? Lavi, give you a minute or two? Yes.
So the answer is the ANS is equal to the all that out there?
Yeah, perfect. Let's do it, okay? So we've got three angles, three sides. It does not matter which one you pick. A suggestion, though, is try and pick the largest unknown angle because we know from the unit circle, you do know from the unit circle, that you cannot take anything sine. You'll never get an answer bigger than 90 for sine. You won't. We learned that from the unit circle, but cosine, you can get cosine of obtuse angles. You cannot get an obtuse angle from sine inverse. Cannot. But you can get an obtuse angle from cosine inverse, okay? So, knowing that, how about we pick angle I? It's the biggest angle, okay? So I always try and pick big. So I try and pick biggest angle. All right, so let's see how this works. So, if that's the angle I want, that's my theta, right? My 7 is an adjacent. My 5 is an adjacent. And my 8 is my opposite. Okay? So pick your angle. And that makes these two my adjacents because I picked that angle. And it makes my 8 the opposite. Thumbs up? Okay, so let's go ahead and set it up. I'm going to go, okay, cosine of I, because that's the angle I want to find, right? Cosine of I is equal to parentheses. I think I've emphasized that enough, huh? Parentheses, got to have parentheses. I'm going to go 5 squared plus 7 squared minus 8 squared, parentheses, divided by parentheses, kind of annoying, huh? 2 times 5 times 7 parentheses. Okay, now, let me show you why the parentheses are so darn important, okay? So, in my calculator, I have to have parentheses because I need that entire amount on the top to be divided by the entire amount on the bottom, right? That's why the parentheses are so important. Because your calculator will do exactly what you say. So if I didn't do the parentheses, just for the heck of it, I'm doing it wrong. I'm doing it way wrong. Hopefully you guys can tell me the obvious. Hopefully you're going to say, no, Mr. Davies.
That doesn't work.
What is wrong with that? Tell me, please. What's being divided?
8 squared and that's 2.
That's it. You agree? That's
Yeah.
it. That would get me all wrong. So parentheses, right? Good. Smart guy. Parentheses 5 squared plus 7 squared minus 8 squared, parentheses divided by parentheses, 2 times 5 times 7. And I get a decimal, which is what I was hoping for, right? And then we'll cosine inverse that, right? Cosine inverse that answer. And I'll get an answer of about 81.8 degrees, okay? So angle I, so the measure of angle I is equal to 81.8 degrees. Okay, now, if you want to find the other two angles, you could do the law of cosines again. You could. But I have a pair of opposites now, right? And here it's a matter of what flavor you like. If you like the law of cosines, you can get the other angle. If you like the law of sines, you can get the other angle. Me, personally, law of sines is easier, right? It's much smaller. So I'm going to get angle G by the law of sines. So I'm going to get the measure of angle G, and I'll use the law of sines because I have my opposites, right? So I'll set up the sine of G over 5, opposites, right? Over 5 equals the sine of 81.8 over 8. Okay, I'm just using a lot of sines. I like my opposites, okay? Have I confused you, or are you okay? Good. It's actually easier than right triangle tree. You guys agree with that?
Yeah.
It's not bad. Okay, bring up the 5, right? And we're going to go to, we're just going to multiply up to 5, so we'll get the sine of G is equal to 5 times the sine of 81.8 divided by 8. And I will get a decimal, I'm sure of that. 5 sine of 81.8. Close the parentheses, divided by 8, and I get a decimal. Sine inverse of that answer, right? And I get an answer of about 38.2. Okay, so angle G is about 38.2 degrees. And then finally, if I need angle P, that's easy. The measure of angle P is from 180. 180 in a triangle, right? 180 degrees in a triangle, so that's easy. You are way ahead of me. I like that. 180 minus 38.2 plus 81.8. Is it really 60? Wow. A nice even one too, huh? Man. I just make these problems up. Okay, and I get an answer about 60 degrees. There you go. Thanks, Daisy. Which is 60 degrees. Okay, what do you think? Law of cosines? Not bad? Right? So it all depends on what you know. So